Okay, so here's a fun challenge that we can think about actually in the coordinate plane. Let's dilate this triangle, so this is a little figure we see here, by a scale factor of 2.5. And the question is, what are the vertices of the image? Now let's just think about this. If we're going to take an object and we're going to dilate by a scale factor that's actually bigger than 1, then that shape is somehow going to get larger. If we're going to actually scale something and dilate it by a scale factor that's smaller than 1, then it's going to shrink a little bit. So since this is actually a scale factor of 2.5, this is actually going to grow. So the first thing we need to do is identify the coordinates of this triangle. So this point right here, this vertex, is 1, 1. This vertex right here is 1, 2.5. And this vertex right here is 2.5, 3. And that's that vertex right there. Now, in order for us to dilate the figure by a scale factor of 2.5, what that means is we're going to take each coordinate and multiply the x and the y by 2.5. And that will identify where the points go. So if I label this, for example, point A, B, and C, we can see where the points go by just doing the multiplication. I'll just do one for you now, and you can do the rest if you want to try. Let's take a look at the point A, which is 1, 1. Where does that go after we dilate by a scale factor of 2.5? Well, it goes to A prime, which is going to be 2.5 times 1, which is 2.5, comma 2.5 times 1, which is another 2.5. So what do we have? We see that this point A gets transformed to the point 2.5, comma 2.5. 2.5, comma 2.5. So right here, it's going to get a little crowded in the picture, but you can see that point. That point is actually A prime, and its coordinates are 2.5, comma 2.5. All right, now we can perform the same multiplication with each of the other coordinates. For example, if we take a look at B, that's 1, 2.5. So if we multiply each of those coordinates by 2.5, the 1 is still going to be 1 times 2.5 is 2.5. But now 2.5 times 2.5 is actually 6.25. So I have to go way up to here to 6.25. The coordinates of this point, 2.5, comma 6.25, and that's where B gets transformed to, so I'm going to call that B prime. And finally, I take the point C, which is 2.5, comma 3, and multiply each coordinate by 2.5, and what do I get? I get 6.25, comma 7.5. So I get 6.25, comma 7.5. And I'm going to call that C prime, since that's the transformed version of C. And now if I connect the dots, put these points together, you see I get the dilated version of the original blue triangle to the new red triangle. And if you look at it, you can sort of see that, yep, it looks like it has the same shape, it just has a different size. And in fact, if you follow these lines back, if you connect the B prime and the B, let me do this in an orangey font. That's actually going to lead right back and go right through to the origin. And that's true with each of these points. If I take the point A prime and connect it with A, it goes back to the origin. And C prime with C, and that's because the center of this dilation is actually at the origin. And so you can see it's almost like sort of like a blooming flower coming out, and you see there's the first version of it, and there's the transformed one. And so you can actually see the fixed point of the dilation. Terrific. Enjoy dilations. They're great fun.